Hello, welcome into a new session of today Cafe with Developer, not Kavička s Developerom, because we will handle the session in English due to the live audience which we have here, an AI conference in Košice. So I would like to welcome Tomáš Koctur. I'm super happy that you are here because it was, let's say, I feel like dilettante in the field of AI, so I'm trying the things and I don't know how it's work and why it's work. So I'm right now happy that I will learn some background about that. So hope that you will help me understand and also audience.
Hi, thank you for having me.
When we thinking how we do the scenario of this Cafe with Developers, we was thinking that it will be good that we will show on some real example how it's work. So we decide to show it on the migration of legacy code to some new language, for example. If maybe the people who was also in my session in AI conference, and they were able to observe that I also presented there. But right now we are just into context. I would like to migrate old code to the new code. And okay, so it's often happened that some manager came and take the, I don't know, some COBOL code and put to the ChatGPT and make me from this code Java code. And they're super happy because it's done. Like that, So my first question is, what is behind all this, that this, let's say, transformation is even possible?
Yeah, just let's start that what we're talking, this is actually really use case, right?
Yeah.
That you are going to do actually in our company. So to transform the old code to the new code, and we see some huge savings in there. So it's important. So how it works? So you decided to use the LLMs, generative AI, to do that. So what is behind that? So we know that LLMs are big hype since last autumn, let's say. It started and now it's everywhere. So how does it work? So maybe we can start with some introduction. What is it and what is behind? But maybe I will start the question. So the core technology of this called transformer model. So do you think when it was developed? Year? Try to guess. It's 2023 this year. Yeah. So maybe
okay,
try.
If I remember that I learned in university, so it's 20 years ago. And
transformer model? No, it shouldn't be 20 years. But
okay, so 15. I finished in 15 or 16 years.
Transformer model was not there.
Okay, so,
yeah, so if we are talking about the deep learning and the NLP, it started heavily in 2012, 2013, 14. And the transformer model came in 2017, actually in one paper. It was published by Google, but they didn't know then it will get so much traction. And first really usable model, BERT, it will came like early 2018. So since then. Yeah, so I have one picture, so explaining the, actually this model, it's a, let's say, theoretical model. It's called the transformer, and it was the replacement for the legacy deep learning technology, which was called recurrent neural networks, or LSTM was one part of it. It was heavily used back then, and only good deep learning technology. And when this came, it created big gap in the advancement. So one part was called one specific NLP, natural language processing task, which was called question answering or reading comprehension. So if you use Google, you ask a question and it will give you answer. So that was the reading comprehension. It was quite hard task. And best models with LSTMs and heavy hacks was working something like 65% in accuracy. It was not very good. But when the Google came with this BERT model, that was like a huge step to 89% or something. It was a very heavy step, and it surpasses the human performance, because no humans are not 100% sure every time, but it surpasses this. So that was great. So if we take, so this is one particular model which is called BERT. But if we have a look on the base model, the transformer, you can see that there are like two parts. First, the left part is the encoder part, and right part is the decoder. And when we started with the transformers, most of the models were just encoder. BERT was just encode the model. It was very good for classification. So you have a sentence, you want to find whether it's spam or not spam, or is this category, or it was heavily used in chatbot, actually, because you need to classify user intent to some state, and then you can form the dialogue. Or maybe you want to find in the sentence some entities like name, surname, IP address, or whatever time. So it was used for token classification. So that was the model, and then it evolves, because this decoder part was very hard in 2017, 2018. So it evolves, it started some models like T5, which was encoder and decoder. So you had first pass from the encoder, and then it was fed to the decoder, and you get some output. And the models get bigger and bigger. And by the getting bigger and bigger, meaning there were more parameters. And what are the parameters? Parameters is if you have because I want to spoiler out, every single neural network is just one equation, very big equation, and I have some x, y, z, and whatever. And it started to have them 1 billion and more parameters, and you need to find what are the values for those parameters by the training those models. So it's starting getting bigger, and it gives the ability to models to actually have some capacity, and actually this capacity allows to model to memorize. And when we started to memorize with this T5 model, which has something like 11 billion parameters, it's starting to not to classify text, to find some questions to the answer, but actually memorize the information and generate the output. That was the first models. But actually it was quite heavy, because you have still encoder part, decoder part, and some guys from OpenAI and also others, not just them, started to use, okay, so what about to just kick out the encoder part and use just decoder? And this is actually the GPT, generative pre-trained transformer. Generative means that they actually put out the encoder and use just decoder. Which was hard back then, because all the models was doing repetitive mistakes. And if you want to just generate some poem or something, you just started repeating some words, and it didn't really work when it was 1 or 5 billion parameters models. And now they scale up to, for example, GPT-3, something like they didn't disclose, but we are talking about the 175 billions, and GPT-4, 1 trillion, which is extremely, it's like, I still compare that as a, in the US, in the car industry, they like to have very big engines, like 8.8, V10, V12, whatever, but they performing like Europeans V6, yeah, sure. It's much smaller. So I don't really see that this will happen to the other models, that they will be bigger and bigger, but they will be reasonable and more efficiently trained, like Llama from Meta does.
I think that we get to this topic, of course.
Yeah, definitely we will. Yeah, and how this model actually works. So what it does, as I said, so this model started to work very well for the reading comprehension, like understand the text, which previous models didn't really do a good job at. So it's work on something called the attention mechanism. And what it is, I will show it on the another picture, is that previous models were recurrent. So every single word or token was fed once in a time. And it was reading from left to right or from right to left or both ways, but it was all the time fed one by one. It was very hard to train and very hard to understand such a problem like this. We have an example. The animal didn't cross the street because it was too tired. And we see the it refers to the animal. But in the other example is the animal didn't cross the street because it was too wide. It wasn't referring to the animal, but it was referring to street. So, and this attention mechanism is actually calculating scores or relations between every single word in the sentence. So, and that was important because if we go from the left to right, for example, it will be always referred to the street.
Okay, and if you,
so yeah, and
otherwise,
yeah, and then these models can actually see the whole sentence. And what was the problem with the recurrent neural networks? That they was recurrent, so every single word was processed one in a time, so it was hard to parallelize on the GPUs. But those are processed in one time. They are bigger, but they can be on the GPU processed at once, which was very huge speed up. And how does it train such a model? It's actually very simple ideas. All of those models are very simple ideas. So, for example, encoder model, how does it train? It gets a lot of data, tons of data. For example, sentences from Wikipedia, from the internet, and from the source. And on the input of the model, we mask roughly 15% of the tokens or the words and the input. And on the output, we show it. And then we can train the model to actually fill the blanks in the sentences. And what it does actually, it can understand the word given the context. And this was one of the concept of the linguistic, that you should know the word by the company it keeps. So, and this is how it trains. This, I mean, the encoder part. The decoder part is different. It's trained by going one by one. So it gets some words and it's trying to compute the other one, and then other one, and then other one. Yeah. So, and what is important on all of those models, that they are, for the GPT, for example, for the decoder part, they trying to be the language model. And language model is a general term which is used for decades. And it's actually, you're trying to find the next word. It's called causal language modeling. You're trying to find the next word. And this is what the decoder part does. So we're trying to train it to predict next and next and next and next word. What we also have, I don't know whether it's for the second topic, but maybe we will put it there.
Okay, so I understand right now that the big change is within this. Let's say that it's understand whole sentence, not just and it's not moving just right or left, and understand and try to understand only next or previous word, or just connection between these words, but whole sentence. So this is why I'm able to get a response from ChatGPT right now, for example, about my transformation from the legacy code to the new code.
Yeah.
Okay. So this is easy, but come back to our use case. So, okay. So this manager did it. So right now it's start work developers or some, let's say, engineers start work on this, and they realize, okay, so it will be nice if I'm able to just put all my code base and just translate, but it's never happening because we have something like it's speaking about it's token limits.
Yeah.
Okay, so I'm not able to put, I don't know, whole book or whole my Git repositories to the ChatGPT and let just translate it because it
to be fair, there are other vendors too. Okay, but GPT. I understand.
Just example, we will also get deeper. So my task right now, okay, so I can do some, I don't know, deployment in some cloud provider with some different models, can do the test, but I will have some results.
Yeah.
Okay, so what is this token limit and why it's this token limit and these models?
Yeah, okay, so let's just define what is the token, because it's a lot of people trying to avoid that word or maybe don't know what it actually is. So if you ask me 7 years ago, before the transformer came, so, or maybe 8 years ago, we always in NLP, when we processing the sentence, which is free text, we're trying to split it to the smaller portions. It can be character level and it also can be word level. So what we used 7 years ago was a word level always. Like no one does anything else because it wasn't really good. But we had some problems that you always, in computer science, you cannot have like infinite number of words in your vocabulary. It's not possible because for Slovak language, for example, you would need over 700,000 words with all the prefixes, suffixes, and if you have a typo, there is another word. So it's hard. So what was developed was called the subword tokenization. Actually, it's a different process. So you have like all the text data, you fit it in, and it's trying to find the most frequent words, and those words are full, like not split it. And the less frequent words are split. And for the Slovak language, it's usually done that, okay, most frequent words are there, less frequent words are splitted by suffix and prefix and suffix, or even it will go down up to the character level. So if you make a typo in the word, for example, you have extremely frequent word, and you make a typo. So what happened? Actually, it will split to the smaller chunks, but it won't be one token, but it will be maybe 3 or 4 tokens.
Understand.
But you don't come to the problem of the out of vocabulary problem. So that's the token. So that's why we use tokens. And for example, as I said, Slovak language has like 600 to 700,000 words in vocabulary. Usually now we use subword tokens, which is like 25,000. So it's like way lower number, 25K for normal vocabulary, for English, for Slovak, it works well. So, or maybe up to 30. If you have a multi-language models, it's bigger, but yeah, it's work well. So this is token. And actually what the GPT or this decoder part of the model, what it does, trying to predict the next token. I have a picture actually, if you can just show it on the screen. So we have, actually there is an encoder block and decoder block. We don't need to focus on the encoder block, but decoder block, and it doesn't really show us up. So let's say we're starting this decoding phase. What it's trying to do is on this top part of the picture, it's trying to predict next token or next word. Will be easier to talk about the words. So first word, and based on that, it will pass this word over down there, and it will try to predict the second word, and then put it down there, then third word, and so on and so on. And the computation will always go through the tokens which were generated. We call it autoregressive models. So the output of your model go to the input of your model, and you're trying to generate next one, and next one, next one, next one. So, and what if you starting to doing some mistakes? Your model is not very good. Then your error goes to the input of your model, and you're generating more errors and more errors. So if you have like infinite number of tokens, then you will go way away from what you want to achieve. So
okay, so it's prevent us to get the worse results.
Yeah, definitely. Yeah, there is one more thing. As I said that back then when they started to use a decoder model, it tends to happen that there were some repetitions and repetitions because the GPT or transformer, it's still a language model. And what the language model does, it's trying to predict next word. And natural ways, okay, so I have like one, let's go to, and then you have like set of probabilities of the next word. And maybe one of the most used will be pub or something, or home, or to the work, or whatever, or I don't know, to the default of our country, whatever. But so you're trying to predict the most probable word. And if you do that, you end up being just very straightforward and repetitive. So they invented something like, so in each step of the generation, they have a probabilities for every single word in the vocabulary. So 25K vocabularies, words. And every single one gets some probability. And then you need to normalize it, which they use as softmax functions. It's hard, but it will show you that, okay, this word is for 85% probable, second one is 12%, and rest of them gets 0.01, for example. All sum to 1. So this actually is very straightforward and gives you most probably word, but this is not they want it. So they introduce something like temperature, and if you were using or advanced settings of the LLMs available, you see the temperature. So what they actually do, they put there some parameter to the softmax function, and actually what they does, if we show it that we have some very probable word, another, and then rest are like this. So this temperature will actually put all the probabilities higher proportionally. So you actually get more creative response.
Okay.
So this was like a huge step in that, because the responses were more natural. So this is what actually happening. And why we don't have an unlimited response, it's one of things. So if you have this temperature, you're actually putting more errors to your generated output, but it will feel more natural. And if you go unlimited, you will go far away. And another one that if you're computing or training your model, it's very complex. We call it quadratic complexity. So more words or more tokens in output, you get on power on 2 complexity. So if you go 512 tokens on square, and if you go one more, it's not just one step, it's square
of the square.
And if you go 100K, you know what I mean. So you want to train the models, you train on GPU. And in order to train on GPU, you need to feed model to your GPU memory, and this is not unlimited. It's not unlimited. So you have to feed it in first, or if you don't train on GPU, on the CPU, you have to put it to your CPU memory, and this is not unlimited. So that's why it's not possible to just have unlimited resources.
Okay. So, and do you see some I would say it's light in the end of this, that it will be on some level more usable? So, for example, we will have, I don't know, 500,000 tokens or.
Yeah, actually, that's that's 500,000 tokens. So we have this code llama with 100K.
Yeah?
Actually, I was very impressed when I saw it. So I realized that they haven't trained it with 100K tokens, but they just train it normally and then extrapolate on the inference time, which was extremely nice. So actually, OpenAI can do that because the architecture doesn't allow that, but the Meta's Llama architecture does allow that. And actually, there's an example. So, for example, you're going to some trip, you want to impress somebody on there. So you want to bring some knowledge with you. So your books, there is some knowledge, and you want to bring it. If you want to bring more knowledge, you need to bring more books. So, and what if your car is not big enough? You buy a bigger car. And if you need more knowledge, what? You buy a bus or airplane or what? So you can really expand your car or let's say make your car bigger. But what if you just learn those things? And then you need just motorbike and go there. So you don't need to bring any book because you know it. And so maybe the outcome or where we are pointing to is to train the model or your custom task. And then you don't need to prompting and you don't need to that much context window.
Okay.
So maybe that would be the way.
I would like to continue with our, let's say, use case. Okay, so we right now know that there is some context-based window, we have some limitation, and one of the biggest problem is that first of all, we need to send some context information to this model. For example, if I would like to translate the legacy code to the new Java, for example, code, then you need to send this old code to the model, and you will get the response. But you can avoid this with this retrieval augmented generation technique, that you can store your, let's say, information in some storage, SQL database or some, let's say, storage. It means that you will save this context-based window on the input. But I know that we speak in front of this session about this, so I'm really interested how it's really work and what is the answer for this.
Yeah, actually, so for the retrieval augmented generation, calls RAG these days, it's actually a new term. So what actually is happening? So you have this GPT model or decoder model, and you have a lot of knowledge, and you want to use it with your questions which you're asking. And for example, we use it for the use case when we have a lot of knowledge base in the database, and user want to ask question, but he don't want to just say, okay, use this documentation for it. Just use our knowledge. So what is actually before the user start asking the questions? So in the first step, we need some data source, which is text files, PDFs, whatever. Then those questions are embedded. And what does it mean? So first step is to split them to the smaller chunks. You cannot have a
so we speak about
it. So what Embedder does is using encoder model, and on the output of the encoder you can have a vector, which is like big array of the numbers, 1D array, or no 1D. It's like used to be in order of hundreds to thousands. And what it does actually in this multi-dimensional space, so if we say we have two numbers for each block of text, and on X and Y axis you have just one number. So in that space, we call it semantic space. So if 2 points are close together, they mean they are semantically close. So if I say I want to watch TV and I'm going to watch television. So different words, same meaning. So they are very close together. But it's hard to compress the information to the 2D array. So if you have like more axes, you can have like more refined semantic context. So more axes give you more ability to more finally find it, more accurate. Yeah. So actually, so this is happening with the encoder. So also OpenAI using also encoder part. Everybody does actually. So this embedder takes the sentence or paragraph, and it will create the vector and store it in the database. And now these days we're using vector databases because if we want to search, we actually we want to find the closest vector, which is hard because you cannot compare it one by one. You need to compare it by some distance, and that's actually it's a new way. So the vector databases that's heavily emerging these days. So we have all the documents, all the paragraphs. They are all embedded to some vectors. Vectors are stored in the database. We can query this database to find the user query. For example, we have user query, so user is asking. We embed this user query, and with this embedding and the vectors in the database, we find the closest matches. Yeah. And with the closest match, we can use these textual representations to this vector, which is also stored in textual representation. We can just put it as a context to the language model and question, and then we get the output. So actually, as I said, so if we have a look on that, so we have on the decoder, we have some context. For example, this is 2 tokens. Then the question, which is 1 token. It will be more tokens, but I'm simplifying. And then we have a generated response to that. And it will generate until it will generate the end of the segment. So this is what is this RAG means. And well, a lot of things are hidden from for example, from the OpenAI. It might happen that if you don't have a limitation, it might happen that the first token is some compressed information. Mm-hmm. That's why you can save some tokens. But usually it's done that the context is fitted first, okay. Then question, and then we get the answer. Yeah.
So in the end, it will not help me. Eh?
Well, I think they reserved some tokens for the context. Yeah. So that's the notes.
Okay. Yeah. Understand. So we have this RAG. Yeah. So and so it's very important for this use case from my point of view because it's understandable that I will not send all my code base to one prompt. Eh? So I need to have some storage. I need to put my data there. Then we need to, let's say, create the indexes, this, let's say, vectors and all this search engine, which is different from different vendors. Eh? So Cognitive Search or Kendra or I don't know, this Google Enterprise, etc. So we have all this set up. Eh? Then, okay, so what could else, what else could help me? So it's what I was thinking. So, okay, so I don't need the model, which have all data about all things in the world. Okay? So like BARD or this, they use this PaLM tool or GPT models. So I just need models which knows code. So maybe one thing what's problem with RAG is that there are like more places. Sorry that I just not directly answering the question, but if we go back to the picture, so there is one, or let's say 2 places, or one place when it can go wrong, and this is this retrieval engine, and the retrieval engine is basically the search engine. So let's just assume that you use the Google, and what if you didn't find the response on the first link? It's likely that it happens, but this will get the first link. And if the link is wrong, you don't get the information. So for example, if we say this is the person, so you go to the nearest pub, you get the smartest guy out of them, you don't know him, and you give him some paper, he can read that paper or read it, and you ask him a question. He still can read from the paper or whatever, but you give him this paper, and you ask him a question. He doesn't know about it, anything. And he's starting to reply. And if your context is good, then the response should be good. Understand.
But if you give him the bad paper, it will be all wrong. But also what might happen, and I was testing it yesterday with the ChatGPT, that I sending some context with the article about the Slovakia. There was how many citizens, and I just put the one sentence that official language is Czech language. And I asked the question, so what is the official language? And he was responding, okay, in the context, I found that you're referring to the Czech language, but actually, I think this is the Slovak language. So actually, as long as the model has encoded or memorized some information about the Slovakia from the previous articles or from the training data, it can also override the context, which is good. But if in this case, but if let's say if your question and your context is far beyond the training data, it will just output it as a Czech language. So just straight away. If he didn't learn anything about the Slovakia and about the other countries, then it would just say it's a Czech language, which is wrong. So this is one thing. And other thing is, I don't know whether it happens to you that you have some really complex question and you ask Google and it will give you some link. Let's say first 5 links, all relevant. But all the page which you then read, it have just some part of the information which you need. And you need to put it together. And this is actually a problem because with this RAG, you just give the first one and there is maybe not the full information. It might be okay and it's not full. And if you specifically asking for that, ChatGPT fill it in. It will just output something because you ask it, but I don't know about anything, but it will just fit it in. So there is one trick for that we will take just, for example, 5 best articles, summarize it, and just fit this to the model.
I have same experience with different use case and the same approach. So it seems that it's like really common that, we are solving these problems with the best approach. But still, I know that this RAG is very interesting, and we can speak a lot about this. But I would also want to touch this let's say specific models, which is domain specific or task specific for our purposes, but is code specific. It's my opinion. I don't know. As I mentioned, I am dilettante, but my opinion is that in the future there will be more models which will be task specific. It will be smaller. Compared to this, let's say, big models like ChatGPT or GPT models, which is learn on whole internet data, or maybe this is the answer. Or I think that this is the answer that use the models which is specific, task-specific models. For
Definitely, I try to refer that in that example with the car, where you can make a car bigger and bigger. Actually, the RAG is kind of the hack on top of the decoder model. It's a hack because you just feed some context and you put it there, or maybe you prompt it and prime it with some other examples and then you get the answer. It's a hack. And always, if you just use it in production, I see some crazy guys trying use the GPT-4, the classification, just say that this is my structure and use it, and you specifically say, don't chat, don't explain, just give it to me, and from 1 over 10, it start to explain or something. You can be really used. But so on this example that you cannot make larger and larger. So yeah, definitely more specific models are required. For example, if we go back, as I said, people now using GPT for the classification task, which is not suitable for.
Exactly.
And for example, we use encoder model for that. And if I said, okay, we started in 2018. So the model which go beyond the human performance, which I mentioned, the BERT base. So as I said, GPT has 175 billion parameters. So try how much was the BERT model parameters. 110 millions. Okay. So it was like 1,000 times smaller, more suitable, more accurate, and actually specific to your task. So you need to use the model right way. For example, if we see this, it's actually connection of encoder and decoder block. This was heavily used in Google Translate. So the foreign sentence was in the encoder block, and the decoder block just generate the response given your input. Works very well. For example, for your use case, I would use this. If we have enough data to pre-train, just use this, and I would bet that it works better and with the smaller model.
So this is also referring to also my speech previously that this large language model is not a Harry Potter magic wand and just do some magic and transfer everything what I want is. So it's will not like that. Exactly. But sorry, I just want to say, but it's very easy to use because right now we have APIs. Developers are very comfortable to use APIs. So it's like right now in the stage that everybody is using it because it's really accessible. And for all other things, you need to have deeper knowledge to some, let's say, different AI fields which you need to identify which models are most suitable for your concrete problems. But right now we have a hammer. Every problem is nail. You know.
Yeah, exactly. It's a big, very big hammer, not just one small. This one. But actually, when I started working in the telecom in 2018 in an NLP field, I would beg anybody just to listen to us about the NLP, something, you know, I would say, oh, it's too much, please don't. Yeah. So I remember one fun story that maybe it was 2018 or something, and I used the BERT model to do this question answering, and I took some article from our Yam page, our social network, about some business trip of our CEO, and I asked some questions, who is this, who was we, and a couple of questions, it was worked well, so I take a screenshot, send it over to some managers. I got no feedback at all in 2018. Now, it's funny that everybody is using it. It's very user accepted it a lot. And also what was good, it's user friendly. So as my team leader said, so who tried ChatGPT don't want to use any other interface than that. So that's true. User accepted it, and we need to
we need to learn people that it's not this magic wand, and we need to speak about it. So this is why we are here.
Yeah. But if we want to talk about the models, okay, so we have the ChatGPT, and we don't want to use RAG. So there's also options. So everybody knows that, as I said, it's a lot of parameters. Training takes thousands of GPU hours and ton of CO2 footprint. So it's not even in our powers in telecom to train our models like fully. We don't have enough data, and we could buy or rent some GPUs on our cloud providers, which are kind of booked out, but sometimes you can get some, but it wouldn't be responsible. Because why we should do something which somebody else did good. So we should talk about the fine-tuning, which is like, okay, we have some models which are pre-trained, available, commercially available, which is nice, and we can fine-tune them.
Actually, this is also one part which I mentioned in my performance on stage, that, for example, that this is the Galactica model. It's a very interesting story about this model was fine-tuned from the GPT, I believe 3 or 3.5 model, and it can produce scientific articles. Yeah. Okay, so I know that you have also funny story about it, but
it was before. I was probably based on Transformer, but not on GPT. It was like I was back in the university on my PhD studies. I generated some article and I wanted to make it very obvious. So because I know that nobody just reading what I post on the Facebook, so I just wanted to make it so obvious. So I put that the co-author is Stephen Hawking. He was back then living. So I put the Stephen Hawking and just put some paper, put it on Facebook. Everybody congratulates me. Nobody really even noticed that I did something with Stephen Hawking. Yeah. So it's very, we should be responsible of that. Yeah.
But come back to this, so it just shows us that we can fine tune the model, which is already created with to the very specific task.
Yeah, as I said, so it's even fine tuning the model. It's the same thing like pre-training. It's the same process, so you need lots and lots of GPUs to train it. What is different that you don't, if you fine-tuning the model, you don't need to take all the data what they used, but you can just use your data to fine-tune on. So it's a little bit less of computation because you have less data, but it's still really hard. And as I said in the previous minutes, that you need to fit model to the GPU or GPUs in order to train it. And this is all, for us, it would mean that we would borrow, let's say, 200 GPUs and train it for 5 minutes. So it's not really possible. So actually what was developed, they call it parameter efficient training. And what they actually do is they take the big language model, which is pre-trained, and they make a small parallel model, very, very small parallel, let's say, 20,000 parameters compared to 275 billion parameters. You don't train the pre-trained model, but you're training just the parallel model with the same data, and then you kind of merge the output, and you get a better result. So, and you can train your model, this parallel model, to your task, and you can store it. It's not very big. You can deploy it, so you can have always one service running your pre-trained model, big model, and couple of your custom models, and just one service which will be just merging those results. And it's possible.
Exactly, this is one of approach which I also utilized a few days ago. So
yeah, so it's very good, and actually it doesn't really. It does take some GPU memory. You can't really do it on your home hardware, but it's much more easier. So for example, we have like server with 2 GPUs with a lot of memory, and we can train I was training the Falcon model, which was 40 billion parameters. It's not hard these days. There are also other methods which are there, but this one gets very popular.
Okay, Tomasz. I think that I just checked the watches and we are speaking a lot of things, but I really feel that I learned many things which is missing for me as a whole picture for the whole context. Believe that our audience is also learn several new things. So we can finish. So thank you, Tomasz, that you are here and you explain us. I also want to thank you, our audience. I'm looking forward for next episodes. So bye bye.
Thank you. Thank you for having me.